Hello, welcome back to Cracking the Cryptic, where we've been asked to have a look at this puzzle from dailykillersudoku.com. It's a 10 out of 10 rated puzzle, so it's going to be pretty difficult. And I suspect the reason we've been asked to look at it is to look at the average solving time for this puzzle, 1 hour 30 minutes. So this is going to be brutal. Now, one thing I'd recommend is if you've not looked at the puzzle, do try it. I think this appeared on Tuesday, so puzzle number 17203. You can find it on the site by searching on the number. But without further ado, let's see why it's so difficult. So I'll just get this in the right position. Hopefully you can see it there on screen. So what can we see? I can see that these three cells must sum up to 15 because we know the row will sum to 45 because it will contain all of the numbers from 1 to 9. You add the numbers 1 to 9, you get 45, which is the most important number in Killer Sudoku. So 18 plus 12 is 30, so these three have to sum to 15. Right, is that going to be of any use at all? Maybe later. This cell we can write in the value of. Same rule again, 45 rule. So this 3 by 3 block we know will contain the numbers from 1 to 9 and therefore must add to 45. We've got cages here that sum to 14 plus 12 is 26, plus 13 is 39. So to get to 45 we need another 6. So let's write that in. Now, okay, so this column now, we've got 22 cage plus a 12 cage, that's 34, plus 6 is 40, so this cell and this cell have to sum up to 5. There are two ways of making 5 in two cells, and we can't decide which is going to work yet, so let's come back to that. Wondering if we can use this 15 total a bit further. Yes, there's a lovely symmetrical arrangement, actually. If you look at this, let's look at this side of the grid first. We know the value of all of these cages, because we know this top one is 15, plus 18 is 33, plus 13 is 46, plus 19 is 65. So, but we know that this 3 by 3 block adds up to 45. Therefore, we know these 4 cells here sum to 20. Now, ordinarily 20 in 4 cells is not a very useful number, but if we look over the other side of the grid, we've got sort of a symmetrical arrangement here, where we can isolate the value of these 4 cells now using the same method. So 18 plus 25 is 43, plus 11, 54, plus 15 is 69. So these 4 cells have to sum to 24. So we've got 24 here, plus 20 here. Well, that's 44. So this cell must be 1 in order to make the whole row add up to 45. And one thing I have noticed with these Daily Killer Sudoku puzzles is they have a very linear solving pattern. And this means two things. Firstly, if you find something like this 1 here, it makes me think that was the next step in the solve, because you remember we managed to isolate these 2 cells to adding up to 5. Now this 1 resolves that this must be a 2-3 combination, because 1-4 can't be used anymore. And it's this sort of, you know, the solve is proceeding in what looks like a very natural, logical way. Now what that means is that if you can find that way, you can make very quick progress. But if you don't find the particular next step that's sort of integrated into the puzzle's DNA, you can be staring at it for hours and not make progress. So, but anyway, we've managed to find that step now. So what would be the next thing to look at? Okay, well, looking at this box, I've got 15 cage and then 11 cage. So that's 26. So I know these 3 cells here sum up to 19. But I know that these two cells are less than 11. So the maximum these two cells can be is 10. Now if they're 10, this would need to be a 9 in order to give us 19 altogether. And obviously if this is less than 10, if this was 9 say, this would have to increase to compensate. So this would have to be a number bigger than 9, which is impossible. So these two cells do add up to 10. And that means these two cells add up to 10. Now can we use that? Well, there's certainly quite a big restriction on these 6 cells now. You can see if these are 10 plus 7 is 17, plus a 2 or a 3. Yeah, there's not going to be too many options for these cells. Certainly if this cell had a small number, that may well break the total along here. But I've just spotted something else as well. This cell. If we look at all 4 columns here, we know all 4 columns add up to 180, which is 45 times 4. But we actually know the value of almost all the cages now in these 4 columns. We don't know the value of that cell, we can't know that. And we don't know the value of this cage, although we do know it will equal this cage. So we actually have an equation here. We know that all of these cages that are contained, where we do know the value of them, plus 2 lots of this number, whatever that is, plus this number equals 180. I'm just going to do some maths on that. Let's just see if that takes us anywhere. So 6 plus 18 is 24, 43, 56, 64, 74, 84, 97, 108, 123, is that? But I've got to add that 15 as well. I thought that sounded a bit low. 123, so that's 138. So 180 minus 138 is 42. So I know this cell plus 2 lots of whatever this cage is has got to equal 42. That's really restricted though, because if this is 8, that would be 2 lots of 17, that's 34. This would have to be an 8 as well. And if this is 7, it's not going to be enough, because 2 lots of 16 is 32. So this would have to be 10. So in fact, believe it or not, that is 8. And this adds up to 17. And this cell has to be an 8. And again, this is lovely now, because this 12 cage gets resolved. This can't be a 2 anymore, because that would give us a 2 here as well. So that's a 3 and that's a 1. This 6 cage can't be 1 and 5 anymore, so it must be 2 and 4. Now, what else can we see? Well, this 12 cage can't contain a 9, because we already have a 3 in the column. So this is 4, 8 or 5, 7. Now that means that this 22 cage does contain a 9. Okay. Now let's think about positions of 8s in these 3 columns down the middle here. If this is an 8, we know that is a 1. If this is an 8, then the 9 is forced up here. We'll have 8 plus 17, 18. This would have to have a 4 as one of these 2 cells. Well, that's going to clash with the 4 we've already got. So this is not an 8. Now, if this is not an 8, the 8 will be down this side, and in fact it'll be in one of those 2 positions. And that means there must be an 8 in that 12 cage. So we can write the 4 and the 8 in. Actually, this 3 here means that we can eliminate the 2 from this position. So this 22 cage now must include the numbers 5 and 7. Keep getting that wrong. Okay, like that. Now, what does that mean? Well, that means there's a 6 in one of these two cages here, one of these two cells, and that fixes this 7 cage. Because now look, let's have a look at this 7 cage. There are 3 ways of making 7 in 2 digits, 1 and 6. Well, 1 and 6 is ruled out because there's already a 1 and a 6 in column 4. So 6 here, 1 here. 2 and 5 is ruled out because there's already a 2 here. So this must be 3 and 4. Now we know these two cells sum to 10. Can't be 2, 8, can't be 3, 7, can't be 4, 6. So this must be 1 and 9. It must be this way round now. 1 contains a 1, must be 1, 5, 7. This must be 2, 3, 9. Which means this can't be a 3 anymore. So that must resolve that way. 2, 3, 9. So this is not a 9 anymore. And these two cells are 3 and 6, which means this cell here is 2 or 5. 3, 6, 3, 6. I feel like I'm being a bit slow about some point around this now. Sorry about that if you're seeing something very obvious. I'm going to put the 5, 6, 7 in along that row. And we have to remember actually these 4 cells sum to 20. Ordinarily not an interesting total, but quite interesting when we can't use the number 1. Because we have to think about where we're going to place a 9 in this 3 by 3 block. So let's just think about that for a second. Obviously the 9 isn't here, it's not here, and it can't be in either of those two positions. So there are 3 cells left that can contain a 9, and I suspect we can show that 2 of these don't work. If this is a 9, these 2 cells have to sum to 10, which means they would have this would have to be a 7 or a 6. But once we get a 9 here, we know this cell, and this cell would have to sum to 11 without using a 1, and that is a massive restriction. So you can see if this is a 6, that just breaks, because these 2 cells would have to be 2 and 3, and if this is a 3, we can't make this 13 cage work. So this would have to be a 3 in that case, which means these 2 cells would have to be 2 and 6. And you can see that I'm sure that where the problem's going here, because if this is 2 and 6 in some order, it would have to be this way round, which would give us this arrangement. And once this is a 7, this has to be a 6. That means this has to be a 3, like that. And look what happens there. This becomes a 6, and this becomes a 2. We get 2 2s. So that doesn't surprise me that this can't be a 9 here. I'm going to be very surprised, frankly, if the 9 is here either, because this gets so congested. But let's check. Can this be a 9? If this is a 9, this will be a 4. You can see because of this 2-4 pair, that's going to force a 4 into this 18 cage, which means that the other 2 numbers have to add to 14. Can't use 6 and 8 for that, so this would become 4, 5 and 9. But that's going to break as well, isn't it? Because once this 9 is here, there cannot be a 9 in these 3 cells, obviously. There cannot be a 9 in any of these cells either, because this 18 cage in 5, if we include a 9 in it, the other 4 numbers would have to add up to 9. Now the minimum you can make 4 numbers add up to in a Killer Sudoku is 10, because 1, 2, 3 and 4 add up to 10. So we'd be forced to have this cell here taking the 9, which means this cell here would have to be a 6, this would have to be a 6, this would have to be a 2, and look, we run into exactly the same problem again. We know these 4 cells add up to 20, so in order to make them add up to 20, I've got to put a 2 in there. Bang, clashes. So, let's see if I can undo that this time rather than... Yes. So we've ruled out a 9 from here, we've ruled out a 9 from here, so the 9 has to be here. And now you can see we've got a 3 and a 3 here, so there's got to be a 3 in one of those 2 squares. Oh, actually no, hang on, I think that's not right. I need to, that's a 3 or a 6, isn't it? So, can't be too presumptuous. So this 9, okay, we know these 3 cells sum to 17, so this has got to be a 1, 2 or a 3. It can't be a 1, so we can remove the 7 there, so this is 5, 6. 2, 3, okay. And now this 20 is forced, I think, because you can see there must be a 4 and a 7 up there somewhere, because we haven't put a 4 and a 7 in this 3 by 3 cage yet. So 4 and 7 add to 11, so the other 2 numbers are going to have to add up to 9, and we have the 3, 6 here. So this is going to be 3, 6, 3, 4, 6, 7 in order to give us our total of 20. That means the other side of this must add up to 24 and must contain the numbers 2, 5, 8 and 9, I think. Let's just tidy up the 9 from there and the 2. So we get the numbers 2 and 9 forced into this part of the grid here. We can do a little bit more tidying up here. Obviously this can't be a 3, otherwise this 19 cage can't be big enough. This can't be a 3 either, this can't be a 4, because that would give us a 9 here, which will clash with this 9. So in fact this 13 cage is a 6, 7, that's lovely. That's going to give us a 5 here, and it's going to give us a 3 here. Well, that's, yeah, that really is helpful. This must be a 2. That can no longer be a 3, look. This can't be a 4 anymore, or a 6. So this has to be a 7, 9 combination, which resolves this as well. Wow. Or it would do if we could type. There we go. 6, 7, so this must be 4. Now you can see this 18 cage is fixed in the sense that it's got to be of the variety 1, 2, 3, 4, 8, because we need to be able to put an 8 in it, because there's no 8 along here because of this 8. So, and we have a 3 and an 8 pair here, so those 2 are 3 and 8, these 2 are 1 and 2, and this must be what? 4, 5 and 6 to give us our 15 total. So this is 279 over here. But we're making reasonable progress actually. It's not too bad so far, this puzzle. This square here has to be a 4 because we already have a 5 and a 6 in the column. This is 5, 6 there. 3, 8, 3, 8. So 3 and an 8 up here. So there's a 3 in one of those 2 cells. Write that down. These 2 add up to 10, don't they? So that's now forced to be 4 and 6, which we know must be that way round because of this 6 here. 6 in the bottom row there. I suspect this 15 is very restricted now. And this 11. Resolve that look. So this must be a 3 or an 8. This is 5 or 7. So you can see 8's not possible now. If this is an 8, this is going to explode. So this is going to have to be a 3. Oh, that's an 8. Which means that this is a 1. I think this has to be a 1 now. That's got to be a 7. This must be 2 and 8. 6. Just do a bit of tidying. You can see that cell now has to be a 5. Because we already have a 1 and a 7 in the row. 4, 8, 2, 8. 9. Move the 3. This 5 here, we can remove 5 from these two positions. Now if this is a 6, these two cells have to add up to 10. Can't be 1, 9, can't be 2, 8, can't be 3, 7, can't be 4, 6. So this is not a 6, this must be a 7. So these have to add up to 9 now. 1, 8 is possible, and 4, 5 is still possible. So 1, 8, 4, 5 into those positions. That slightly surprises me, but I think it looks right. And there's there's a lovely bit of logic we can use here. We have a 3 in this position and a 3 in this position. So how do they affect this 3 by 3 block? Well, they force a 3 into one of those 4 squares. Now, if this is a 3, we can see this equal sign between the cages here. So that's going to give us these 3 cells have to sum to 9 without using a 3. Now there's 2, 3, 4, that's ruled out. 5, 1, 3, that's ruled out. So this would have to be 6, 1, 2. But we already have 2 6's here. So this can't be 6, 1, 2. So this cannot be a 3. There must be a 3 in this cage. Must be helpful. Just see we can actually write in the value of that cell. That's got to be a 5, look. That is useful. That gives us a 7 there, 9 here. 5, 7, 9. So this is a 5, 8 pair, which means this must be 6, 7 pair. And we have a 7 there, so this is not 7. 7, 6, 6, 6, 6 along there, look. And this 11 cage now is quite restricted. We can see this can't be a 2, because if it's a 2 this will be a 9, so let's remove the 2. It can't be a 5, because then this would be a 6. So this is, let's remove that. So this is 8 or 9. Ah, look, and if this is a 9, this will be a 2, and that will clash here. There'll be no way of filling this 18 square. So this is not a 9 either. This is an 8, and that is probably going to be very useful as well. That gives us a 3 there. Move lots of things now. This can't be 1, 8 now. This is 4, 5. Can't have an 8 there. Can't have a 5 there. This 15 cage now, we know these two numbers have to add to 10, so this has got to be, this square here has got to be 1 or 8. 2, 9, 2, 9. But this square here has got to be a 1. It's the only thing left for this box. So this can't be a 1. So that's got to be like that. 9, 9. This 3 here means these can't be 3, so this is the 3. Oh, it must be so close to finishing this off now. 1, 2 and 4 into this position. Okay, I think we're going to have to look at the options for this cell to just finish this off. 1 isn't possible because this would have to add up to 7. Can't have a 3 in that total. 2, that's possible if this was 4 and 1 in that order. What about 5? That would give us 3 and 4 are ruled out by those two, obviously. 5, these have to add up to 8 now. Can't be 1 and 7, can't be 3 and 5, can't be 2 and 6 because we already have 2 6s there. So 5 is not possible, 6 obviously is not possible. 7 or 8 would be the other possibilities looking at this. So 7 would be 13. These two cells would have to sum up to 10. And looks like 1 and 9 is the only remaining option. And there's a 9 there, so this would have to be a 9. And if this is 8, 14, these would have to add up to 11. 2, 9, 3, 8, 4, 7, 5, 6. So it would have to be 2 and 9. And that would have to be, so that would have to be 1 or 2, and this would have to be the 9. So very restricted here. 1, 2, 4, and 9. But simple Sudoku rules tell us there's got to be a 5 in one of these 3 squares. So that can only go there now. So 2, 6, that can't be a 2, look. So what are we left with now? We've got 4, 6, 7, and 9 to place. So that's 4, 7, 9. So this can't be a 3, so it's got to be a 3, 2, 9, 2, 8, 9. Where can a 1 go in this block? I think it can only go here. Well, that's useful. So what did we say? 8 here would give us 14, so 8's no longer possible as an option for this cell. So where now do we place an 8 along here? It's all going to, I think that's the end of it, isn't it? That's going to finish it. That's going to have to be 7, that means that's the 4. It's not a 4. It's 2, 8. Yeah, and there we go. So yeah, very difficult. Not absolutely monstrous, but certainly required a little bit of effort today to crack that one. Let's just check that we're on the right lines. Down here, we're looking for 6, 8, and 9 to finish this. So that can't be 8, that can't be 9. 6, 9, 6, 9. This is going to have to be 8. With along here, we're left with 4, 5, and 6. That means this is a 5. That must be a 6 after all that, which means this is the, oops, that's not that, that's that. It resolves this way round for the 6, 9 combination down there. 9, 2, and I hope that this was helpful to your own solving of these very difficult Killer Sudoku puzzles. If you enjoy the channel, please subscribe, we really appreciate it. We'll be back soon with another edition of Cracking the Cryptic.